Hi everyone, I'm Layalina Mayan from BS Biology 22. Today I will discuss my topic on Chapter 8 entitled How Have Human Activities Affected Marine Ecosystem? The impacts of human activities on land and in the water can influence ecosystem profoundly. Climate change, ocean acidification, permafrost melting, habitat loss, eutrophication, stormwater runoff, air pollution, contaminants, and invasive species are among many problems facing with the ecosystem. Human activities are disrupting and degrading marine systems. Here are the major threats to marine systems, which are coastal development, overfishing, runoff of non-point source pollution, point source pollution, habitat destruction, introduction of invasive species, climate change from human activities, and lastly, pollution of coastal wetlands and estuaries. The first one is coastal development. Coastal development is defined as the human-induced change of the landscape within sight of the coastline. This includes building structures that are on near the coast in general for protection, commerce, communication, or recreation. These structures support economic and social activities that can contribute with positive or negative effects on the coastal environment. Worldwide, almost 2.5 billion people, 40% of the world's population, currently live within 100 km of the coast, adding increased pressure to coastal ecosystems. Coastal development linked to the human settlements, industry, aquaculture, or infrastructure can cause severe impacts on nearshore ecosystems, particularly coral reefs. Coastal development impacts may be direct, such as landfilling, dredging, and coral and sand mining for construction, or indirect, such as increased runoff of sediments and pollutants. Next one is overfishing. Fishing is one of the most significant drivers of declines in ocean wildlife populations. Catching fish is not inherently bad for the ocean, except for when vessels catch fish faster than stocks can replenish, something called overfishing. The number of overfished stocks globally has tripled in half a century, and today fully one-third of the world's assessed fisheries are currently pushed beyond their biological limits, according to the Food and Agriculture Organization of the United Nations. Overfishing is closely tied to bycatch, the capture of unwanted sea life while fishing for a different species. This too is a serious marine threat that causes the needless loss of billions of fish, along with hundreds of thousands of sea turtles and cetaceans. The damage done by overfishing goes beyond the marine environment, and billions of people rely on fish for protein, and fishing is the principal livelihood for millions of people around the world. Many people who make a living catching, selling, and buying fish are working to improve how the world manage and conserve ocean resources. Based on WWF work with a cross-section of stakeholders to reform fisheries management globally, it is focusing on sustainable practices that not only conserve ecosystems but also sustain livelihoods and ensure food security. In overfishing, alam naman natin na ang pangunahing kabuhayan ng bawat tao ay ang pangingisda na siyang sumusuporta sa bawat pamilya. But when too many fish are taken out of the ocean, it creates an imbalance that can erode the food web and lead to a loss of other important marine life, and it becomes too depleted to recover. Next is runoff of non-point source. As the runoff moves, it picks up and carries away natural and human-made pollutants, finally depositing them into lakes, rivers, wetlands, and coastal waters and groundwaters. Non-point source pollution can include excess fertilizers, herbicides, and insecticides from agricultural lands and residential areas, oil, grease, and toxic chemicals from urban runoff and energy production, sediment from improperly managed construction sites, crop and forest lands, and eroding stream banks, salt from irrigation practices and acid drainage from abandoned mines, bacteria and nutrients from livestock, pet waste and faulty septic systems, atmospheric deposition, and hydromodification. The runoff of non-point source is caused when rainfall moving over and through the ground. It picks up and carries natural and human-made pollutants, which are depositing them into lakes, rivers, wetlands, coastal waters, and groundwaters. Next is the point source pollution. Factories and power plants can be a point source pollution. It is affecting both air and water. Smokestacks may spew carbon monoxide, heavy metal, sulfur dioxide, nitrogen dioxide, or particulate matter, which is small particles, into the air. Oil refineries, paper mills, and auto plants that use water as part of their manufacturing processes can discharge effluent wastewater containing harmful chemical pollutants into river, lakes, or the ocean. Municipal wastewater treatment plants are another common source of point source pollution. Effluent from a treatment plant can introduce nutrients and harmful microbes into waterways. Nutrients can cause a rampant growth of algae in the water. Ang point source pollution naman are pollutants that discharge through a pipe or other conduit from a specific discharge, such as an industry or municipal treatment. For example is industrial plant, which is the factories, oil refineries, pulp and paper mills, chemical manufacturers, automobile manufacturers, food processors, pharmaceutical manufacturers. The pollutants are oil, thermal pollution, toxic chemicals, heavy metals, and pharmaceutical. Sewage treatment plants, the pollutants is the nutrients and bacteria. Let us proceed to the habitat destruction. Human impact on terrestrial marine natural resources result in marine and coastal degradation, population growth. Urbanization, industrialization, and tourism are all factors. In 1994, it was estimated that 37% of the global population lived within 60 km of the coast. Poverty, consumption, and land use patterns contribute to the degradation of marine habitats and to the destruction of species that rely on them to survive. Examples of habitat destruction are deforestation, dredging rivers, bottom trawling, and urbanization. Next is introduction of invasive species. An invasive species is an organism that causes ecological or economic harm in a new environment where it is not native. Invasive species are primarily spread by human activities, often unintentionally. People and the goods we use travel around the world very quickly, and they often carry an invited species with them. Ships can carry aquatic organisms in their ballast water, while smaller boats may carry them on their propellers. Insects can get into wood shipping pallets and creates that a ship around the world. Some ornamental plants can escape into the wild and become invasive, and some invasive species are intentionally or accidentally released pets. For example, is the Burmese python are becoming a big problem in Everglades. In addition, higher average of temperatures and change in rain and snow patterns caused by climate change will enable some invasive plant species such as garlic, mustard, kudzu, and purple leucostrife to move into new areas. Insect pest infestation will be more severe as pests such as mountain pine beetle are able to take advantage of drought-weak plants. Ang introduction of invasive species are very harmful to our natural resources. like fish, wildlife, plant, and overall ecosystem health because they disrupt natural communities and ecological processes. Next is climate change from human activities. Humans are increasingly influencing the climates and the Earth's temperature by burning fossil fuels, cutting down forests, and farming livestock. Certain gases in the atmosphere block heat from escaping. Long-lived gases that remain semi-permanently in the atmosphere and do not respond physically or chemically to change in temperature are described as forcing climate change. Gases such as water vapor, which respond physically or chemically to change in temperature, are seen as feedbacks. Human activity is increasing the concentration of some of them in the atmosphere in particular, which are the carbon dioxide, methane, nitrous oxide, and fluorinated gases. Climate change from human activities. Human is the main cause of climate change because of the human activities like burning fossil fuels such as oil, gas, can harm to our planet. It is because fossil fuel can release carbon dioxide into the air that causes the planet to heat up. Next one is pollution of coastal wetlands and estuaries. Estuaries are impacted by pressures from human activities as well as natural events such as storms and flood. The greatest threat to estuaries is by far their large-scale conversion by draining, filling, damming, or dredging. These activities result in the immediate destruction and loss of estuarine habitats. Until the last few decades, many estuary habitats in North America were drained and converted into agricultural areas. Others were filled to create shipping port and expand urban areas. In the United States, almost 38% of the wetlands associated with coastal areas have been lost to these types of activities. In some areas, the estuarine habitat loss is as high as 60% of the remaining estuaries around the world. Many seriously degraded by pollution, people have historically viewed estuaries and waterways as places to discard the unwanted byproducts of civilization. Pollution is probably the most important threat to water quality in estuaries. Poor water quality affects most estuarine organisms, including commercially important fish and shellfish. The pollutants that have the greatest impact on the health of estuaries include toxic substances like chemicals and heavy metals, nutrient pollution or eutrophication, and pathogens such as bacteria and viruses. So here are the class Bacillariophyceae. This is the diatoms, most abundant phytoplanktons, major oceanic primary producer, cell wall composed of silica glass-like. It lives alone or in chains. The shape of this is centric or pennate. This is also the Dinophyta, the Dinoflagellates. It is abundant in warm surface H2O in tropics, some symbiotic of Zooxanthellae. It lives in coral, clams, urchins, and anemones. It gives carbohydrates and receives nutrients and shelter. Give coral their vibrant color. So why do dinos produce light? Camouflage. When it senses a predator motion in H2O, it attracts larger predators that could consume the would-be dino predator. So here the chart of dinoflagellate bloom of red tides. It is mass development of dinoflagellates discolor water, often caused by excess nutrients. It enters ocean from land runoff and fertilizer sewage. This is the impact of the red tide, which is toxic to marine life, accumulates in clams, mussels, scallops, fish, mammals. It can cause of death to some species by biomagnification, also human poisoning after consumption over 30 minutes. The symptoms of these are paralytic, paralysis, asthma, heart attack, neurotoxic, tingling paralysis, memory loss, diuretic, cramps, vomiting, and diarrhea. So here are the pictures show the impacts of the red tide in ocean and in the other species. Measuring primary production. Satellites measure differences in sea surface color. The color type of producer. The green color is the chlorophyll pigments. So here are another chart of productivity limitation. It shows the color. The brown color is the low productivity, the blue is moderate, while the green is high productivity and the violet is very high. Eutrophication, light availability on deep season and latitude. This is the little photosynthesis below 100 meter over almost 330 feet. The phytoplankton productivity limited to photic zone. So here are the chart of light availability. In North Pole, almost 60° north, low angle of incoming sunlight, 30° north, Tropic of Cancer, 0° equator, sunlight directly overhead, Tropic of Capricorn, almost 30° south, the low angle of incoming sunlight, 60° south of South Pole. Here are the chart of nutrient availability, natural fertilizer. Upwelling aids primary production by bringing nutrients to the surface, nitrogen and phosphorus, caused by winds blowing either parallel or offshore along a coastline. It brings up cold, nutrient-rich water. In the surface is the nutrient-poor water, while yung nasa baba is nutrient-rich water. So here are another chart. This is the zooplankton fecal pellets that leads to future phytoplankton blooms need bacteria to decompose waste. Here are the water temperature, the diatoms like cool H2O. The higher temperature is on spring. This is also the chart of phytoplankton season and latitude. So, phytoplankton versus zooplankton. This is the chart. Next is, why are freshwater ecosystems important? Freshwater is lifeblood of our plants. Freshwater ecosystems that connect people and animals with resources they need to thrive. It is also play a fundamental ecological role and provide economically important products and services. These provide critical habitats for a large number of aquatic plants, fishes, reptiles, birds, and mammals. They host many migratory and threatened species of birds, reptiles, and fish. Water stands in some freshwater systems and flows in others. First is standing. This is the lentic bodies of water, which are lakes, ponds, inland wetlands. Next is flowing, which is the aiotic systems of fresh water, which are streams and rivers. Formation of lakes that have four zones based on deep and distance from the shore, which are the littoral zone, the top layer near the shore. Second is the lemnetic zone, open sunlit layer away from the shore extend to deep and penetrated by light. Next is profundal zone, deep open water, too dark for photosynthesis. And last is the benthic zone, bottom of lake, mostly decomposers, detritus, feeders, and some fish. So here are the chart of stratification by deep distance from the shore. This is also the picture show the distinct zone of life in a very deep temperate zone like lake. Without the availability to refill water and insulate from the cold water, birds and mammals will die from hypothermia. Juvenile sea turtles can also become trapped in oil and mistake it for food. Dolphins and whales can inhale oil, which can affect lungs, immune functions, and reproduction. Many birds and animals also ingest oil when they try to clean themselves, which can poison them. Fish, shellfish, and corals may not be exposed immediately but can come into contact with oil if it is mixed into the water column. Shellfish can also be exposed in the intertidal zone. So, here are the stratification by temperature. The first one is epilemnion. Epilemnion is the topmost layer of water that interacts with the wind and sunlight. It becomes the warmest and contains the most dissolved oxygen. The next one is a hypolemnion. It is the lower layer of water in the stratified lake, typically cooler than the water above and relatively stagnant. Oligotropic lakes. It is low levels of nutrients and low net primary productivity. Next one is Geotropic Lakes. High levels of nutrients and high net primary productivity. Mesotropic lakes. The cultural eutrophication leads to hypereutrophic lakes. Here are the pictures show the effect of nutrients enrichment on a lake. Next is the three aquatic life zones. The first is source zone. This is the headwaters and mountain streams swiftly flow. It increases low DO levels, lack nutrients, low productivity. The next is transition zone, which is the headwater streams merge to form wider and warmer streams. Gentle slopes, high turbidity, less DO, moderate productivity. Next one is floodplain zone. Friction from water modifies land. It is high temperatures, low DO, high productivity, murky water, erosion. So here are the three aquatic zone. The first one is the source zone, second is transition zone, and last is the floodplain zone. Freshwater inland wetlands are the vital sponges. Marshes, swamps, peripottles, floodplains, Arctic tundra in summer. It provides free ecological and economic services. It can also filter and degrade toxic waste, reduce flooding and erosion. It helps to replenish streams and recharge groundwater aquifers. This is also biodiversity and food and timber and recreation areas. What is turbidity? It is the measure of degree to which the water loses its transparency. Due to the presence of suspended particulates, the more total suspended solid in the water, the darker it seems and the higher the turbidity. So what are the consequences of high turbidity? The suspended particles scatters the light, decrease the photosynthetic activity of plants and algae, contributes to lowering the oxygen and concentration even more, and there are the various parameters influencing the cloudiness of the water. Some of these are phytoplankton, sediments from erosion, the suspended sediments from the bottom, which is frequently stirred up by bottom feeders like carp, waste discharge, algae growth, urban runoff. Suspended particles absorb heat from the sunlight, which is turbid waters become warmer, reduce the concentration of oxygen in the water, and that's all. Thank you.